This is the GMAT 41. You are welcome to our elementary mathematics class. In this class, we introduce quadratic equation. First, what is a quadratic equation? It is a polynomial of degree 2. A quadratic equation is that polynomial in which the highest power of the unknown, the highest power of the variable is 2. Take note, we have what we refer to as quadratic expression and quadratic equation. Expression and equation are similar, is that okay? The only difference is that in equation, you always make the expression equal to something. In an equation, you must have equality sign. That's just the difference. You recall that under polynomial in previous classes, we encountered the concept of the degree of a polynomial. So, telling us that a quadratic equation is a polynomial of degree 2, it's no longer a new word to us. The degree of a polynomial is simply the highest power of the unknown of the variable in that given polynomial. The important point here is this, that the highest power of the unknown, the degree of the variable in the given quadratic equation is what? 2. That's what defines a quadratic equation for us. The general form of quadratic equation is ax squared plus bx plus c equal to 0. Is that okay? Now, let's see other forms in which this quadratic equation can take, depending on when a particular term is equal to 0 there. For it to be a quadratic equation, this coefficient a can never be 0. Take note of that. A is either less than or greater than 0. Okay, but what if this coefficient of x, which is b, is equal to 0? Take note that a and b are coefficients of x squared and x respectively. If this b is equal to 0, this will become 0 times x, and of course you know that this term will become 0. We'll be left with ax squared plus c equal to 0. Look at it. So this is a reduced form in which quadratic equation can take. What if the constant term c, the term that is independent of x, it does not contain x, what if that term is equal to 0? If c is equal to 0, then the quadratic equation will reduce to ax squared plus bx equal to 0. Is that okay? Alright, now having seen the general form of quadratic equation, we now want to look at the methods we can use in solving quadratic equations. To obtain a solution of quadratic equations, there are 4 major methods that have been specified, and here we have them on the board. Alright, we have the factorization method, we have completing the square method, we have quadratic formula method, and we have graphical method. The quadratic formula is sometimes called the almighty formula. Now take note of this, that factorization method can solve some kind of questions, some kind of quadratic equations. But there are other types of quadratic equation that it cannot solve. Now I'm talking about completing the square method, quadratic formula method, graphical method. These 3 other methods solve any form of quadratic equation. Our interest in this video is to explain completing the square method. Like stated before the break, this method is extremely important to quadratic equation, you know. Number 1, it can solve any form of quadratic equation, just like the quadratic formula and graphical method. Are you following? But one interesting thing is that the completing the square method is actually the method that was used to obtain the quadratic formula. Is that okay? So we want to quickly go through that. Imagine you're given ax squared plus bx plus c equal to 0 as a quadratic equation. Please take note, we've chosen to use plus plus plus. It's not compulsory that in the given question it must all be plus. You can also be given questions where you have negative signs there. Is that okay? So in completing the square method, what do you do first? The first thing is to divide through by the coefficient of x squared. In completing the square method, the coefficient of x squared is expected to be 1. Now, if it must be 1, it means we have to divide this quadratic equation through by the coefficient of x squared, which is a. So divide ax squared here by a, you'll be left with 1x squared, or simply x squared. Divide this bx by a, you'll be left with ba times x, that's b over a times x rather, b over a times x. Then divide this c by a, you have c over a. Go over here and divide 0 by a. If you divide 0 by a, you get 0. Then next, transfer this constant term to the right hand side. Transfer this constant term, this term that does not contain x, which is c over a. Transfer it to the right hand side. If plus c over a is moving to the right hand side, it's going to change to minus, is that so? So we'll be left with x squared plus b over a times x equal to minus c over a. At this point, we're going to do something very significant. And what is that? We would find half of the coefficient of x. 1/2 of the coefficient of x is simply 1 over 2 times b over a. Is that okay? Because the coefficient of x is b over a. So half of it is simply 1 over 2 times that b over a. What would we do to this 1 over 2 times b over a? Of course, you know that 1 times b will give us b. Then we now have a 2 times a, which will give us b over 2a. So this is 1/2 the coefficient of x. Is that okay? 1/2 the coefficient of x is simply b over 2a. So we're going to square that b over 2a and add it to the left and right hand side of the given equation here. Is that okay? So let us do that and see. B over 2a in brackets squared. We'll add it to the left hand side, we'll add it to the right hand side. And that is what I've done here. If you look at that, I used red marker to add it up. To the left hand side, you can see that x squared plus b over a times x, then we add b over 2a in brackets squared, equal to the right hand side minus c over a, you can see that, then plus this term b squared over 4a squared. I decided to apply power law of indices to the square of half of the coefficient of x, which we got here already. If you open up this bracket, remember power law of indices is going to be b raised to the power 2, which is b squared, then 2a raised to the power 2, which is going to give us 2 raised to the power 2, which is 4, a raised to the power 2, which is a squared. Remember that power distributes over what? Multiplication and division. I stated that under laws of indices. Okay, now having got this equation, what do we do from here? Now look at the left hand side of this equation. You'll notice we have x squared plus b over a times x plus b over 2a, all in bracket raised to the power 2. The left hand side has two squares, two square terms. One for x squared, the other b over 2a squared. Now at this point, we will combine these terms that bear square. We'll combine them and close them in bracket and put the square outside. Is that okay? So let us do that and see. You're going to have x, which is this x, then b over 2a, look at it, and close this in bracket and square it. Is that okay? Listen, if you expand these brackets with this square, you will get back this expression here. So mathematically, you are correct. Nothing is wrong with what you've done here. Is that okay? Then that will be equal to, come to the right hand side, this is addition of fraction, so definitely you go through LCM. LCM of the denominator is 4a squared. That 4a squared divided by a, we left with 4a. 4a times minus c will give us minus 4ac. Plus 4a squared divided by 4a squared will give us 1. 1 times b squared, we have b squared here. That's correct. At this point, we are solving for x. We want to get the value of x. X here is enclosed in bracket with square outside. So what do? We need to remove this square. And to remove square, we take square root of the left hand side and square root of the right hand side. If you take square root of the left and of the right, this square will disappear. Remember, once again, under laws of indices, you notice that square root simply means raised to the power 1/2. So that raised to the power 1/2 will cancel these 2 here. Is that okay? So give us power 1 here. Then equal to, introduce the square roots to the right hand side of the equation. Please take note, square roots distribute over division. Which means if you take square root of this right hand side, it's simply the same as square root of all the numerators and square root of the denominator. Is that okay? So what are we going to get here? By introducing square root to the right hand side, that makes you introduce plus minus. Whenever you're introducing square root to a term, the result could either be plus or what? Minus. So we introduce that, okay? Now, at this point, you can work out this right hand side. The numerator will be maintained exactly as it is. Because of this minus, square root cannot be distributed to this b squared and 4ac. Please take note. Under surd, we're going to treat laws of surd. Square root does not distribute over addition and subtraction, but it distributes over multiplication and division. Take note. So we maintain the numerator like that. Then coming to the denominator, square root of 4a squared. This is 4 times a squared. So it's going to be square root of 4, which produces 2, then times square root of a squared, which produces a. Does that make sense? Now at this point, we now have x plus b over 2a equal to plus minus square root b squared minus 4ac all over 2a. This b all over 2a will cross to the right hand side. If this plus b over 2a moves to the right hand side, it's going to become minus b over 2a plus minus this whole term. Alright? Okay, now if you have minus b over 2a plus minus all this term here, their denominators are the same, 2a, 2a. So you can actually combine the numerators. Is that okay? You can combine the numerators, which is going to be minus b on the right hand side. This b cross will become minus b, then plus minus this numerator, square root b squared minus 4ac. Then all divided by the common denominator. And that actually gives us this equation we have here. I call it equation alpha. This equation is the quadratic formula. This equation is also referred to as the almighty formula. Is that okay? We're going to call it more of quadratic formula. Now, why did we take our time to explain this concept? Let's say this part of this equation, square root b squared minus 4ac. The term inside that square root, which is b squared minus 4ac, is extremely important to us. It gives us important information, and we call it the discriminant of a quadratic equation. In the next video, we're going to see the importance of this discriminant as to how it can help us to determine the roots of a quadratic equation. In the previous video, we looked at the quadratic formula derived from the completing the square method of quadratic equation. It was stated that there is this part of this quadratic formula that is very, very important to us, and this part is the square root b squared minus 4ac part. Now, this term inside the square root, that is that term enclosed by the square root, b squared minus 4ac, is known as the discriminant of the quadratic equation. Look at it, b squared minus 4ac. We refer to it as what? The discriminant. This discriminant is very important as it gives us the following vital information. You'd like to know about that, right? Now let us look at the information that this discriminant, we're going to use d to represent it. Is that okay? Let's see the various information that it can give to us. As we have on the short note and board, it tells us about the type of roots of quadratic equation that a particular quadratic equation will produce. And that's not all. It also goes ahead to tell us whether a quadratic equation can be factorized or not. Remember, one of the ways of solving the quadratic equation is by factorization. That is one of the methods. So as to whether a given quadratic equation can be factorizable or not, this discriminant gives us information about that. You won't recall, I stated in the previous video that not all quadratic equations can be solved by factorization method. So if you want to know the ones that cannot be solved, you can use this to test for it. Alright, now let us look at the types of roots of a quadratic equation dependent on the discriminant. The first one, if you observe that b squared minus 4ac is greater than 0, that is, if the discriminant is greater than 0, then we expect that that quadratic equation, the roots, also known as the zeros of the quadratic equation, will be real numbers and unequal. For example, you can solve and get something like x equal to 3, x equal to minus 1, x equal to 1, x equal to 4, things like that. These are real numbers and they are not equal. So when a quadratic equation is given to you, even before solving it, if you're able to check for b squared minus 4ac, you would get to know whether the roots you're going to get will be real roots and unequal. That is so if the discriminant is greater than what? 0. Now, for a situation where the discriminant of the quadratic equation is greater than 0, the graph of that quadratic equation, if you graph it, are you following right? The graph will cut the real axis at two different points. The real axis is the x-axis. Take note. The real axis is the x-axis. Is that okay? So the graph will cut the x-axis at 2 points. In the next video, we're going to see how these graphs look like. Alright, now the next is if the discriminant b squared minus 4ac is equal to 0, then you expect that the roots or zeros of the quadratic equation will be real numbers, but this time around they will be equal. Remember, in this case, they will be unequal when it is greater than 0. But when the discriminant is equal to 0, you will get real numbers as the roots of the equation, as the solution of the quadratic equation, and these real numbers will be equal. So one could think of, okay, solve the quadratic equation and you get x equal to 2 and x equal to 2. That is x equal to 2 twice. Or you get x equal to minus 1 and x equal to minus 1. That is x equal to minus 1 twice, 2 times. So that happens if the discriminant is equal to 0. So once again, even before solving the quadratic equation, one can tell whether the roots are real and equal using this. The graph of such quadratic equation will cut the real axis, the horizontal axis, is that okay, the x-axis just at one point. It will touch the horizontal axis, the real axis just at one point, because the value is repeated at that point. Is that okay? Alright. The last aspect is when the discriminant is less than 0. So b squared minus 4ac is less than 0. In this case, the type of roots we are going to get are referred to as complex roots. Complex root. That's why we introduce the concept of imaginary number I. This is when the discriminant, once again, is less than 0. For the discriminant to be less than 0, it means that these terms inside will be negative. And square root of a negative number is imaginary. Is that okay? It doesn't really exist. The root is presented in this form, that x is equal to alpha plus minus I beta. This alpha is the real part, and then beta is the imaginary part of a solution. Under complex number, we're going to see the concept of real and imaginary part. Generally, complex number z is equal to the real part plus IC. Where the C there is the complex number part. If you graph the quadratic equation under a situation where b squared minus 4ac, the discriminant is less than 0, the graph will not touch the real axis. It will not touch the real axis. Take note of that. The reason is this. If you come to your graph, this is real axis, alright? Real axis, that is the horizontal x. and then y is imaginary axis. Imaginary axis. Imaginary axis. That is what y is, alright, and we use I for it. We use I for it. So this graph will not touch this real axis. The graph can only be seen hanging on the y axis. In the next video, we're going to see the graph of each of these cases. Then we shall now state under what condition can a quadratic equation be factorizable using the concept of discriminant. In this video now, we want to look at the various graphs of a quadratic equation depending on the discriminant and the sign of the coefficient of x squared, which is a. That's whether a is positive or negative. You know, if it is positive, it means that the value of a is greater than 0. And then if it is negative, it means the value of a is less than 0, right? That is talking about a, the coefficient of x squared. But okay, now previously we already identified 3 different roots of the quadratic equation that we may get depending on the discriminant b squared minus 4ac. And so let us see how it works here. In the first case, we talked about real and unequal roots. Now, if the quadratic equation is such that the discriminant, alright, is greater than 0, you expect to get real and unequal roots. Like we stated from the previous video, alright, that the graph will cut the real axis, which is x-axis, at 2 points. So you can see that. Look at one point there, look at another point. Please take like this point now is negative and this is positive. Please take that the graph will also be such that the value cut either the positive side 2 times or the negative side 2 times. It's possible, alright? Maybe you have it something like this. Something like this. You can see the values here. Is that okay? Or maybe you have the graph this way. You can see the 2 values on the positive x-axis. Is that okay? So take note of that. It's not compulsory that it must cut the negative and the positive sign of x. But the main point we are highlighting here is the graph is going to cut the real axis at 2 points. Is that okay? Now the graph or the curve can open upward, facing up, just like you have it here. If the coefficient of x squared, which is a, is greater than 0, that is if it is positive. Is that okay? And in this case, x1 will not be equal to x2 because they are real and unequal roots. This graph and this graph are similar. The only difference is, in this case, where the curve opens downward, the coefficient of x squared in the quadratic equation, which is a, in this case, will be less than 0. And less than 0 means it's going to be negative. Okay, now the second aspect is when we have real and equal roots. This is how the graph will look like. You can see at this point, the curve touch the real axis just at 1 point. So at that point, x1 is equal to what? x2. That's what we refer to it as real and what? Equal roots. That happens if the discriminant is equal to 0, like we learned from the previous class, or the previous video rather. Of course, this curve opening upward simply means that a is greater than what? 0. Then in this case, it's also similar to this graph. The only difference is the curve opens downward because the coefficient of x squared, which is a, is less than what? 0. That is a negative value. Just imagine you're given minus 2x raised to power 2, alright, minus 2x raised to power plus 5x minus 1 equal to 0. You can see the coefficient of x squared is minus, so it's minus 2, isn't it? So fine, in that case the curve will face downward, it will open downward. Then this is real and equal roots. Then in this case, when we have complex roots or imaginary roots, is that okay? You can see the curve here. The curve did not touch x-axis at all. It hung up on y-axis. Because this curve did not touch the x-axis, the real axis, it means that the root of the equation here is going to be complex roots. This happens if the discriminant is less than 0, we stated that before. And of course, a again is greater than 0 so that the curve will open upward. The curve is not going to open downward, alright? The curve opens upward. Does that make sense? Because for the curve to open downward, in this case, a is expected to be negative. And once a is negative, this can never be less than 0. Take note of that. If a is negative, this can never be less than 0 because minus 4 times that minus a value will make this positive. Is that okay? That is why in this case 3 we have just one curve for it which opens upward. Now we've analyzed all this graph. The reason for that is an examiner can actually dribble you into this, asking you a question, okay, what's going to be the value of an unknown constant in a given quadratic equation such that maybe the equation will have real roots. The equation will have real and equal roots, so that the equation will now produce complex roots. Or you were told so that the graph will cut x-axis or touch x-axis, or such that the graph will not touch x-axis. You know, such kind of question are solved using this knowledge that we've explicated so far. And hence, in the next video, we should start by looking at the question and this. We're going to take 3 questions, one at a time, to explain this concept here on the board. We've got the very first question here on the board, and how we can apply the discriminant and the solved problem. And then look at this question: for what range of lambda will the graph of 3 lambda plus 1 in bracket times x squared plus lambda plus 2 in bracket times x plus 1 equal to 0 not touch the x-axis? So we have to find the value of lambda, for which if you plot the graph of this quadratic equation, it's not going to touch the x-axis. Of course, when you take your mind back to what we've learned from previous video, for the graph of a quadratic equation not to touch the real axis, not to touch the x-axis, then the discriminant is expected to be less than 0. Is that not so? And hence, we're going to impose that condition here. So let us start. We have 3 lambda plus 1. We're multiplying it by x squared plus lambda plus 2. We're multiplying by x plus 1 equal to 0. Clearly, from here, you know that going by quadratic equation, the coefficient of x squared is a, the coefficient of x is b, and the constant term is what? C. Now, for this condition, for the graph not to touch x-axis, the implication is that the discriminant, which is equal to b squared minus 4ac, is expected to be less than 0. That's the condition. So we're going to substitute into this discriminant and then make it less than 0 and solve the inequality we are going to get there. So let us go. It implies that this is going to be b squared. Our b here is what? Lambda plus 2. So we have lambda plus 2. We're going to square that. Then minus 4 times a. The a here is 3 lambda plus 1. So we have 3 lambda plus 1. And then we're going to multiply by c. And c is what? 1. This will be less than what? 0 for the condition imposed in this question. Now let us simplify out and solve this quadratic inequality we have here. If we expand this bracket, we're going to get lambda squared plus 4 lambda, then plus 4. Come over here, open up this bracket. 1 times this bracket will still give you this bracket. And minus 4 will open this bracket. Minus 4 times 3 lambda is going to give us minus 12 lambda. Minus 4 times plus 1 will give us minus 4. All 10 less than what? 0. Observe this inequality at this point and take note that this plus 4 will cancel out this minus 4. 4 minus 4 is 0. Then again, you have 4 lambda minus 12 lambda. 4 lambda minus 12 lambda is going to give us minus 8 lambda. So from this, we now have lambda squared minus 8 lambda to be less than or equal to 0. This is a quadratic inequality. So we can check if we can factorize this quadratic inequality. Of course, it's factorizable. What is common to this term and this term? You can see that lambda is common to both. So we're going to factorize the lambda. If lambda comes out, use the lambda to divide lambda squared. You have lambda in bracket, use the lambda to divide minus 8 lambda, and then you have minus 8. This is less than 0. Okay, for the product of 2 terms to be less than 0, you are given 2 numbers because you have this lambda and you have this bracket, lambda minus 0, lambda minus 8 rather. You are multiplying this lambda by this bracket. For 2 terms to be multiplied, in order to get answer that is less than 0, then it means that 1 out of those 2 terms must be less than 0. Take note of that condition, please. Put it down. I repeat that. For 2 terms to be multiplied to get a result that is less than 0, it means that 1 of them must be less than 0. And 1 of them being less than 0 means that 1 must be negative, the other will be positive. Does that make sense? For example, if you have minus 2 times plus 5, the result you're going to get will be minus 10, which is less than 0. So here we're going to impose 2 cases. Case 1 and case 2. Although for this problem, we would be a bit safe. You might not punish yourself in the cases, but there's some questions given to you. You have no choice than to impose those conditions. For that being the case, I'm going to impose a condition here. Let's learn it from this first question. Remember, for 2 numbers to be multiplied to get something less than 0, 1 of those numbers must be less than 0. So at this point, I'm going to write case 1. Case 1. That case 1 would be that, okay, let lambda be less than 0 and lambda minus 8 be greater than 0. Remember, one of the 2 terms must be less than 0. Therefore, the other one would be greater than 0. So on this, we have lambda is less than 0 and lambda is greater than 8 here if we solve for this. So think about this. We are coming back to this analysis to see which one would be the correct result. Okay, case 2. In case 2, we are not going to change the order of the arrangement here. The order would be that in this case, let lambda be greater than 0 now. So lambda should be greater than 0 and of course remember, one of them must be less than 0. So if lambda is greater than 0, then the bracket lambda minus 8 will be less than what? 0. So solving out this, lambda is greater than 0 and here we have that lambda is less than 8. So look at these 2 cases in real life. Which one is true? Lambda is a number. There's a constant. So imagine that here, lambda, are you following, is less than 0. And that's saying lambda is greater than 0. Does it make sense? A number is less than 0. That's a number you're saying is greater than 8. Case 1. It doesn't make sense. If a number cannot be less than 0 and at the same time greater than what? 8. So this is impossible. I'm going to cancel that and then write impossible. Then look at this. This is lambda is greater than 0 and lambda is less than 8. Do you know it's possible for a number to be greater than 0, but that number is not up to 8? Think about 1, think about 2, 3, 4, 5, 6, 7. All these numbers are greater than 0, but they are less than what? 8. So in real life situation, case 2 is possible. So that becomes our result, possible. Therefore, the range based on that question is going to be that lambda here is greater than 0. For lambda to be greater than 0, it means that 0 is less than lambda. So I'm going to rewrite it that this case, this will give us lambda is greater than 0 or 0 is less than lambda. Then this we still maintain that lambda is less than 8. Therefore, our result becomes 0 is less than lambda is less than 8. This is how we solve this problem. And that's the solution to this question we have. In this video, we now want to consider this question. We are asked to find the least value of k, that is the smallest value of k for which this equation k minus 1 in bracket times x squared plus 2x plus k minus 1 equal to 0 has real roots. Now, how do we approach this question? This time around, you notice that a condition imposed on this quadratic equation is that the roots are what? Real. Mind you, the question did not specify whether the roots are unequal or whether the roots are equal. It didn't specify. It didn't tell us that this is real and equal root. This is real and unequal root. Nothing was mentioned about that. We only told that the roots are what? Real. Now, if you take your mind back to a discriminant of a quadratic equation, you notice that there are two cases where we had real roots. One of them is that roots may be real and equal. The other is roots may be real and unequal. So we're going to combine those two cases to solve this problem. Since there is no specification as to whether it is real and equal or real and unequal. We know there are two cases for real roots. So we'll combine those two cases and then see what this is going to give to us. So let's go. We have k minus 1 multiplied by x squared plus 2x plus k minus 1. That is equal to 0. From there we can identify our a. Coefficient of x squared is a. Here coefficient of x is b. And then this constant term is what? C. Now for this condition, okay, that the roots are real. It implies that a discriminant d, which is equal to b squared minus 4ac, is expected to be greater than or equal to 0. Get greater than is a case where you produce unequal roots. And then equal to is the case where you produce what? Equal roots. But both cases will give you real numbers. We can now substitute into this discriminant formula and see our b is 2. So it's going to be 2 squared minus 4 times a is k minus 1 multiplied by c. And c is also k minus 1. This is greater than or equal to 0. Now I can multiply all these parts and see what I'm going to get, but let's write it as 2 squared minus this 4 also is a perfect square, so permit me to write it as 2 squared. I saw something here that made me choose to write everything as perfect square term. That is just equal to 2, alright? K minus 1 times k minus 1 is the same as k minus 1 all squared, so greater than or equal to 0. Remember, if you have a term like this is difference of two squares. There are two terms, and look at one of them, 2 raised to power 2. Then look at another one, is that okay? So let me put down something here as a reminder. Recall, if you have a squared minus b squared, it's going to give you a minus b, then times a plus b. We refer to it as difference of two squares. So I'm going to use that to solve this problem. Okay, assuming this is a and then this whole term is b, then it implies that this is going to give us, I'll pick 2 from here, pick minus. Alright, then I'll have 2 times this k minus 1, 2 bracket k minus 1. All these terms in bracket, just like you have this a minus b. Then in the second part again, I'm going to pick this 2. Then this time around it will be plus, no longer minus. Look at it. Then pick this whole term here without the squares. That's going to be 2 bracket k minus 1. Then you enclose. This is expected to be greater than or equal to what? 0. Now we can open up the internal bracket and then simplify. So let's do that and see what this is going to give to us. This will be 2 minus 2 times k will give us minus 2k. Then minus 2 times minus 1 will give us plus 2. And then do the same thing for this bracket. You have 2 here. Then plus 2 times k will give us plus 2k. And plus 2 times minus 1 is going to give us minus 2. Enclose this and greater than or equal to 0. If you simplify this, 2 plus 2 is going to give us 4 minus 2k. And then coming over here, you'll agree with me that this 2 will go off with this 2. Then we'll be left with what? 2k. Greater than or equal to 0. Now what does it imply here? Do you know that 2 is common to all these terms here? 2 is common, so I can still choose to reduce it. I can still choose to reduce by dividing through by 2, which is common. Let's do that and see. Divide this by 2, you would have what? You would have 2 left here. Divide this minus 2k by 2, you would have a minus k. In bracket, and come over here, divide this 2k by 2, you're going to get k. Then come over here, divide 0 by 2, you'll still be left with what? 0. So this is what we are going to deal with. Is that okay? We're going to formulate 2 cases from here as usual. Now imagine 2 terms are being multiplied and we're expecting to get a result that is greater than or equal to 0. Now I'm going to ask you this. For 2 terms to be multiplied so that the result will be equal to something that is greater than 0 or equal to 0, what does that tell you? Listen to this and put it down. It simply means that 2 of those terms must be greater than 0. That's one condition. Or 2 of these terms must be less than 0. Put this down, is that okay? And then quickly think of this again. Imagine you have minus 2 and minus 5. Minus 2 is less than 0. Minus 5 is less than 0. If you multiply 2 of them, you will get plus 10. And plus 10, the result is greater than 0. Satisfying this, is that not so? Then again, look at this. Imagine you now have plus 2 and plus 5. Positive, positive. Each of them greater than 0. If you multiply 2 and 5, positive numbers, you're going to get 10, which is also positive, greater than 0. So we're going to apply those two conditions here. Is that okay? Case 1 and case 2. So let's go. Case 1. Case 1, we are taking it that each of them are, let's say, greater than 0. So we go 2 minus k is greater than or equal to 0, or we have that k is greater than or equal to 0. Under these two cases, if you multiply this k and 2 minus k, you will get something greater than 0. So let us solve from here and see. From this part, it implies that 2 is greater than or equal to k if k crosses. Or, come over here, k is greater than or equal to 0. What is the implication of these? This simply means that k is less than or equal to 2. For 2 to be greater than or equal to k means that k is smaller. Is that okay? Or equal to 2. Then over here, this k is greater than or equal to 0. K greater than or equal to 0 simply means that 0 is less than or equal to k. That's the implication. Is that also? Fine, look at this case and think about it. In real life, I believe this case is possible. But let's try the second case and see. Let's try the second case, case 2. But like I said, look at this case. K is less than or equal to 2, or 0 is less than or equal to k. It's possible. It's possible that you have a number that is greater than or equal to 0, but that number is less than what? 2. Think of 1. Is 1 not greater than 0? But that one is less than what? 2. So we found, let me mark this and say this is possible in real life. Possible in real life. So we'll get our result from here. Let's just work on the second case, just for clarity purposes. Is that okay? Now, case 2, we are taking it that the product of these two terms, each of them should be less than 0. Okay, in that case, we're going to have 2 minus k less than or equal to 0, or we have k is less than or equal to 0. Solving out this, it implies that 2 is less than or equal to k, or k is less than or equal to 0. Now, what is the implication of these? Let's find out. For 2 to be less than or equal to k simply means that k is greater than or equal to what? 2. And here, k is less than or equal to 0. So here, k is less than or equal to 0. So we're going to ask ourselves this question. In the real world, can you have a number that is greater than or equal to 2, and then that same number is less than or equal to 0? It's not possible. A number cannot be less than 0 and then greater than 2. So this is impossible. Impossible. It's not possible. Is that okay? Therefore, we can now conclude. Therefore, we can now say that the correct answer is case 1, which is this. And this one, to write it out, case 1 is correct. Case 1 is acceptable. Is acceptable. Alright? And if it is acceptable, the range would be that 0 is less than or equal to k. Look at it. And that k is less than or equal to 2. So that's the range. But coming to this question, we have to find the least value of k. The least value of k. So let me conclude the result here. Least value of k means the smallest value of k. In this range, the value of k starts from 0 and end at what? 2. Therefore, the smallest value will be what? 0. Hence, the least value of k is 0. K is equal to 0 for this. And that is the solution of this problem on the board.